so we have 20 minutes for the presentation and another 10 minutes for questions and answers. The floor is yours.
Okay. Assalamu alaikum. As the title is, Design of Algebraic Concept Operator for Adaptive Feedback in Physics. The title looks a bit technical, but actually it's not. Although the subject is artificial intelligence, but I will present it in a very humanity kind of aspect, because mostly it's about adaptive learning. I am a co-author. Actually, the author is Andrew Bimba, but unfortunately he couldn't make it to come to the conference. And I am videotaping myself and upload that to YouTube as I do usually, so people can access this presentation. And also other, this is actually a part of his PhD thesis, so it's an ongoing study, and I will tell you at the end of the last slide where we are in that study of his research. And most of us are like supervisors of Mr. Bimba. Here we'll talk just introduction about the feedback, the problem, research motivation, objectives, methodology, and proposed solution. Well, everybody knows what is a feedback since we were young at school. Somebody will tell you about your performance, good, bad. Somebody will tell you about, give you a dialogue, do this, don't do that, close this. Somebody will do an action. And we all believe that a good feedback means, I mean, although there is no reference for that, but there are a lot, I did not include that. A good feedback equals improved learning or student learning. When we hear about feedback, normally it's a generic feedback. You do something and you get a quick response, and normally in the classroom, whether the traditional way or the automated way. Traditional way, sit down, yes, you're good, no, do this again. So this is the generic feedback. I don't want to go through definitions, I mean, it's just there. We are here actually, and this research focuses on the adaptive feedback. The difference between generic feedback and adaptive feedback, the adaptive feedback means that the feedback that you are getting is dynamic, so it changes according to your behavior. So it changes according to your level of knowledge, according to your learning style, according to the things that you like, according to the way you think. So adaptive feedback is actually a part of artificial intelligence if we are going to design an adaptive system. And I like this tailoring feedback. So the generic feedback, we would like to tailor it to suit every single one or student. Of course, I mean, when you talk about adaptive feedback, you are talking about personalization. So everybody gets what, which you say personal tutor, I mean, if you have a tutor coming to teach somebody, well, that tutor could go in different paths according to the different needs of the individuals or individual learners. Now, in order to design and develop and come up with adaptive machine or adaptive systems, especially in the learning aspect, you need to understand like the pedagogy. I mean, since I was a PhD student, even my supervisor could not really pronounce the pedagogical or pedagogy, okay? Maybe doctor, you're familiar with that more than me. Pedagogy, okay, which is the way of learning and the methods and the tools. So we need to understand the students or the learner, which instructional method that suits him. So it really depends from a learner to another learner. Also, if we want to provide a feedback, there is a domain. I mean, if I'm going to learn physics, then the domain of knowledge is physics. If it's something else, the domain. So we need to identify the domain and how deep we are going in, whether are you going to provide a problem, solution, question, feedback. Also, we need to know about the student. The student, as you know, level of performance is different between one to another. Some of them slow, some of them fast. Their knowledge level, some of them you find the students in your class, some of them they have a lot of information, they are more knowledgeable than others. Also the cognitive learning style. Some of them feel dependent, some of them feel independent, some of them visual, some of them they listen more or they read. It depends on the culture and the individuals as well. Now, the adaptive feedback means everyone can work alone and getting exactly what he needs. And in order to achieve this, we have to understand this pedagogical model, domain, and learner model, as we just explained before. Again, in order to understand the different personal characteristics of people, whether learners or shoppers, we are talking about businesses or marketing. Now, the prior knowledge, it's important to understand the prior knowledge. So when that student gets into the system can recognize the level of knowledge, so he can jump him instead of going to introductory. Okay, so he get into the the more let's say complicated subjects or topics. Also the learning progress, it depends on the students, and the learning style. Maybe we can see some of the different learning styles, and even brothers or sisters at the same house, they have different learning styles. One of them could be musical, one of them logical, one of them natural, visual, textual. So in order to provide this personalization, we really need to understand these learning styles according to each individual. Again, why adaptive feedback? We need to understand who does better than the others. Students who excel most and those who excel less. Now, as we talked before, pedagogy, domain, and students, we also, based on that, we can adapt these things according to the strategies, which are means, target, goal, and strategy. What are these? These are called adaptive feedback characteristics. If we look at the strategy, we can understand that some students like to go top down or bottom up, or active, reactive learners. If we look at the goal, which is the pedagogical reason, they learn by reinforcement, others by correct errors, some of them by just receiving information. If we look at the feedback target, then we can understand the teaching techniques that suits everybody, such as inquiry learning, problem solving, or deductive or inductive. Also, the learner characteristics in terms of the feedback mean, what's the level cognitive learning style of each individual student. Understanding these and the learner domain, pedagogy, and the learner characteristics, we can, understanding learner information, the learner information, we know the learner and how much information they have, can be used to provide adaptive feedback. The aspect of the instructional system, the way of teaching, also can be adapted to learner characteristics. The pedagogical reasons for providing feedback based on the learner model. The steps taken in providing feedback based on changes in student proficiency. So all of these aspects get us into the motivation that we believe that there is insufficient research of the design of multiple adaptive feedback characteristics on students' performance. Our finding through the research and the literature, we find that there are many knowledge-based techniques that are used, such as linguistic knowledge-based, expert knowledge-based, and ontology. And unfortunately, these are involve a manual knowledge elicitation process. So the main objective of this research is to develop the autonomous adaptive feedback model in physics, because the topic that are going to be used, I will explain it later, is physics. So looking at developing adaptive feedback model in order to evaluate its effectiveness on student learning. And to achieve this, we need to look at the cognitive knowledge base. Now, the cognitive knowledge base is the one that combines these three knowledge-based systems, and also providing, based on that, an algebra using concept algebra. That I will show you the algebra. So, to design our question objective, to design a model for representing multiple adaptive feedback characteristics. Also to know how can multiple adaptive feedback characteristics be models within an adaptive learning environment. Again, problem clarification, model design, development, implementation, and then evaluation through the process. I will not go into explain these in you know, the textual things: problem clarification, model design, development, implementation, and evaluation. These are the process where, so now, based on the things that I've introduced and talked about and explained, this is the conceptual model that we are proposing. And if you look at the domain, there is a domain and student, and the cognitive, the one up there. This represents the pedagogical. You can see that students have performance have scores, score, fair, good, whatever. So if you can see the tree, you can see the relations between these nodes. So you can jump from here and get the sociology that's related to cognitive apprenticeship. And so these are correlated together in order to come up and to understand the behavior of each single student. So we can design and develop an adaptive feedback system that suits individual. And these nodes, the nodes of the proposed model, represent concepts in the pedagogy domain and student model in the adaptive learning environment. This is the framework that are used in order to come up with the equation or the formula, which is this one. Actually, this is the formula, the algebraic concept relation. And these are these are like a subset. The domain, the performance of the students is a subset of the domain, students, and pedagogy. Okay, so this is very complicated formula, but implementing these formulas hopefully will be like a programming systems in order to provide the adaptive feedback. And why we chose the physics? It's because it has a level of difficulty, presence of misconceptions, degree of logical precision, reasoning required, mathematics skills is required for physics, and misinterpretation of question posed, and concept gaps. So actually, physics is a very complicated topic, and we thought it's an interesting topic for a university first year student. So this is the system that was developed. This system will be applied. Just a quick, students when they get into the system, they just log in into the system, and username. Every student has a username and password. And when they click on the problems, these are like 10 sessions. Each session have about 9 questions. So when they go into the problem. They choose the first. The problem will come in after choosing the domain. See, the sound is not working here, but I will just reach the end of the video where the student here answered the question and he submit his answer. So the more questions the student use, the more the system become intelligent. So the more users, the more intelligent the system becomes. And adjusting to the point where, so that now the student, when he gets into here, like he finished session 7, which he finished only 2 problems, he can come back and finish the other 7 problems. And the good thing, when he go to the dashboard, okay, he see, now if you see the dashboard, his average, he did this errors, and he's in field independent and expert learner based on just the 2 questions. So the more questions, the system can understand his behavior. What is next? Now, the researchers, they have 50 students as a first year university students. They have taken the pre-university level, so they are like 17, 18 years old, to do physics. First, all of them will do the pre-test, and then the control group, there will be 15 students solve problems with no feedback at all. So it's like the normal system. 15 students will solve the problems with generic feedback, not the adaptive one. 20 of them will use the system with the adaptive feedback. And after that, all of them will do the post-test. This is just to examine whether the adaptive feedback system can be really helpful in terms of learning. We can conclude this, that providing feedback based on individual characteristics is the key to bridge the gap between students who excel most and students who excel less. Also, we design a model to investigate the effect of multiple adaptive feedback characteristics on student performance. Now, we are going to measure their performance by doing the pre-test and the post-test. Also, the main contribution of this research is to design an algebraic concept operator for multiple adaptive feedback. So this operator is going to be used to evaluate student performance on learning physics. That's it for me, if you have any questions.
Thank you. So, do you have any questions?
Is the system adaptive in the notes only, or is the system, the feedback system, adaptive on the pathways? As well.